Hello friends, welcome to CEC Live Lectures. Dear friends, we would like to announce that from today onwards we are starting a new series in the area of computer science. Our new series is on cloud computing because this is the first session in this series. So dear friends, we would like to tell you all that today we are going to know what cloud computing is. So the topic is Introduction to Cloud Computing, and for the discussion on the topic we have with us in our studios Dr. Kashish Ara Shakil. Dr. Kashish Ara Shakil is Assistant Professor in Department of Computer Science and Engineering, Jamia Hamdard. So let's welcome our guest, Dr. Kashish Ara Shakil, and let's try to understand what cloud computing is. Hello ma'am, welcome to the lecture.
Hi. Hello dear listeners, I'm Dr. Kashish Ara Shakil and I'm working as an Assistant Professor at the Department of Computer Science, Jamia Hamdard. And now, today we are going to talk about the term cloud computing, what cloud computing is all about. I'm sure you must have all heard about cloud. So why the term cloud? Because the data, the computing, nothing is within your hands. It's stored far away, similar to a cloud in literal terms. So now let's begin with what cloud computing is all about. So these are the things we'll be covering up in today's lecture. What cloud computing is, we'll be looking at the different perspectives of cloud computing, the different properties and characteristics of cloud computing, the benefits which can be gained from cloud computing, and the different service deployment models. So now let's begin with what this word cloud computing is all about. So whenever you want milk with your breakfast, there are two options which are available to you. Either you can go and buy a cow, or you can go and buy bottled milk. So in case you are going to buy a cow, there is a big upfront cost which is involved. You usually end up producing more than you need. And of course, it uses a lot of resources. How the resources are being utilized, you need to place your cow somewhere, you need to dump the waste, so you will be needing a lot of inventory. And of course, there will be a lot of time which will be spent in maintaining it. And of course, there will be a lot of waste product which will be involved, and of course, it will be very unpleasant. So, another option available to you is you can go to the market and you can go and buy the bottled milk itself. So if you're going for bottled milk, there will be a continued cost and you will buy only what you will need. And of course, it will be less resource intensive. Why it will be less resource intensive? Because you no longer need to buy a cow. So no resources are involved. What is involved? You just need to go to the market, go and get the milk. And there will be no maintenance. So the only maintenance involved here is just to store it in the refrigerator. And of course, you don't have to care about the waste because there's no dung which will be involved, nothing at all. So you must have wondered that why we are talking about cow and bottled milk here. Since we are dealing with cloud computing today, then why are we talking about cow and bottled milk? So well, this cow can be considered analogous to your traditional computing, your traditional computer system, and this bottled milk is nothing but cloud computing technology. So how this cow is similar to your computer? In case of your computer, there is a big upfront cost which is involved. You usually end up producing more than you need, because what is happening here is your system might be supporting 2 TB of data, and you might be only using up to say 1 GB of space in your system, and you have to use up a lot of resources because your system might be running 24/7 and the productive hours could be only say 1 hour in a day. So at the end of the day, you are using a lot of resources which are getting wasted. And of course, there's a lot of time which is spent in maintaining it, because you will be needing a resource person who will be maintaining your system. There will be someone who will be taking care of the electricity, then other stuffs like air conditioning, since your server might be a high-end server. So that will be a problem. Then another problem would be there will be a lot of unpleasant waste. How do you think will be an unpleasant waste in case of your computer? Yeah, your computer also produces a lot of unpleasant waste in form of heat which is being produced. That is why you usually have air conditions in your laboratories. Another unpleasant waste is in form of noise which is coming out of your computers, and then a lot of space is also occupied. So this also you can say is a kind of unpleasant waste. Then how cloud computing can be considered analogous to a bottled milk. Because in case you're going for cloud computing, you don't need to have a high-end server installed in your place. What you need to do is you just need to log into your system. And use the computing resources which are being provided by the service providers. So what are the different service providers we have? We have different service providers like Amazon, which offers services like Amazon EC2, and then it offers data management services like Amazon S3. Then you have Yahoo, which is offering you cloud services, and EMC. So in fact, cloud computing, you must have heard about it in the recent times. But cloud computing is not just a recent technology, because cloud computing has been used since a long time. Ever since you've been using, say, email. Your email is nothing but it's a kind of cloud services which is being provided to you. So saying that cloud just evolved is not right, because you have been somewhere down the other been using these services since a long time. And of course, in cloud, these services are provided as per your usage. So for example, if you're going for an Amazon cloud, what you have to do is you have to pay only, say, as little as 10 cents for around 1.7 GB of memory and 1.2 gigahertz of processor and 350 GB of storage. So which one do you think is a better option, cloud computing or going for a traditional system? Well, it depends upon your usage. If you need you have really high-end needs and you have lack of resources, so I think cloud computing is the one you should go for. So let's look at some of the traditional definitions of cloud computing. NIST, which is National Institute of Standards and Technologies, they have proposed a definition of cloud computing which says cloud is nothing but a model for enabling convenient, on-demand network access to a shared pool of configurable computing resources. So what are these computing resources which you can use? You can use different computing resources like network, server, then you can use different applications and softwares as a service. So what is happening here? How these services are being provisioned to you? These services are being provisioned to you by something called as a service provider. So what a service provider does? A service provider is basically an entity. It's a real life entity which provides you with cloud services. So how the service providers, they are providing you with these services? They have some kind of resources at their back end, and through these resources they are providing you these services, and these services, mind you, they are being shared by multiple tenants or multiple clients. But as an end user, what you feel is that these services, they are being dedicated to you, and you are the only sole user of these services, which is not true. So what is happening here is you are being provided these services which are shared across multiple tenants. So NIST also says that this cloud model, it promotes high availability and is composed of 5 essential characteristics. So what are these characteristics? These we will be looking for in the upcoming series. Then it provides us with different service models. So until now there are 3 service models, and then we have different cloud deployment models also. So we'll be looking into the details of all the service models and how the deployment takes place in the upcoming series. Next definition was proposed by Berkeley. According to Berkeley, cloud computing, it refers to both the applications which are delivered over the internet and the hardware system and softwares in the data centers that provide these services. So according to them, these services are generally referred to as software as a service, and the data center hardware and software is what we call a cloud. So what is happening here is you are being provided with a pool of resources, and these resources are being offered to you as a service. And how these services are being offered to you? They are being offered to you like utility computing. So what utility computing is? Utility computing is nothing but it is like using the computing resources in a utility-like manner. I'm sure you must have all paid your electricity bill, and how these electricity bills are being paid to you? You are being paid according to the amount of kilowatt hours you are utilizing. So similarly, cloud computing can also be used as a utility. What you are doing here is you are paying only for the amount that you are utilizing. So if you're using 50 GB of RAM, you're paying for 50 GB of RAMs. And if you're using, say, 100 GB of storage, so you are going to pay according to that. So this kind of payment mechanism is called as pay per usage. And the way in which these kind of computing resources are being provided to you, this way is called utility computing. Another definition was proposed by Dr. Rajkumar Bhuiya. He is one of the topmost experts in the field of cloud computing, and he has a lab also called as Clouds Lab at Australia, Melbourne. According to him, cloud is a type of parallel and distributed system consisting of a collection of interconnected and virtualized computers. And what these computers do, these interconnected virtualized computers do, is they provide you computing resources in a dynamic manner, and they present you these services in a unified computing manner based on a service level agreement which is established between the service providers and the consumers. So what a service level agreement is? So I'm sure you must have all used software. So before installing any kind of software, what happens is you are bound to sign a service level agreement. When you click a check mark, so what is happening here is you are agreeing to the way in which this software will be used. So in a similar manner, you are using the computing resources, and in this case, what is happening is you are entering a service level agreement with the service provider. So what is there in the service level agreement? You are agreeing that these resources I'll be utilizing, this much amount of RAM will be provided, and these are how the services will be provided. And for the service provider end, what the service provider does is, the service provider, it says like, okay, you'll be given these services and this is how much I'm going to charge for it. So everything is mentioned in a service level agreement, and this agreement is signed upon by negotiation between the consumers and these cloud service providers. And all these resources, these resources are being provided to you in a dynamic manner. So you're not aware where these resources are coming from. You're not aware how these resources are increased, decreased depending upon your resources. What you are aware of, you are just provided with a unified system that is being provisioned to you, and you're not aware where these resources are coming from, whether your resource usage is increasing, decreasing. You are not aware of anything. Everything is taken care of by the cloud computing framework itself. So another definition was proposed. So these are the different definitions which have been proposed about cloud computing. Now let's look at what are the different components of cloud computing. So a cloud system, a cloud ecosystem, it comprises of cloud, which is of course the main entity. Then you have clients, cloud service providers, and you have virtual computers. So when you have to use these cloud resources, a client, will connect to a cloud service provider. How this connection is established? It's all established via an internet. So if there's no internet, cloud services will fail. So you need a good internet connection. So all these resources will be provided to you over the internet, and the clients, they will connect to the cloud. So these clients can connect via their laptops, they can connect via any kind of PDA devices, they can connect by tablets, mobile phones, anything which can use internet. The cloud clients will connect with the cloud service provider, and what the cloud service provider will do, it will provision you with the kind of resources you have requested for. And how these resources are being provided by the service provider. The service provider will be having virtual computers at their data centers at their end, and virtual servers which will be used for provisioning these resources to you. So this is the entire cloud ecosystem comprising of clients, cloud service provider, and at the back end we have the virtualization, all the virtual computers. So virtualization is a kind of backbone of cloud computing, which is supporting this entire technology called cloud computing, and of course internet. Without internet, cloud computing is nothing. So let's look at the 3 schema architecture which has been proposed about cloud computing. According to this architecture, there are basically 3 levels at which cloud computing is being provided to you. So you have client level, you have service provider level, and then you have the data center level. So you as a client, as an end user, will be at the client level, and then you will be accessing these services which are being provided to you by the service provider through either applications or through user interface or through machine interface. Machine interface is nothing but any device you are using through that interface, and of course you will be some kind of application, some kind of API will be involved for you to connect to the client system, to the service provider UI. So what the service provider will cater for, it will first of all, it will cater for the kind of services which are being provided to you. Then the service provider will take care of the pricing scheme. So you don't have to worry about the pricing. They will have some automatic mechanism by which they will monitor how the resources are being utilized, and on the basis of these resources only you will be charged. Then they will also take care of the fact that the SLA is agreed for. So you are not using more than what you required, and you are not being charged for more than which is required. So SLA will also be taken care of by the service provider itself. Then monitoring will also be taken care of by the service provider. So the service provider at their end will have certain monitoring tools. So one of the famous monitoring tool is Ganglion, which is being used. So what these monitoring tools they do is they will monitor how these services are being provided, and how much resources a particular user, a particular task is using. So all these things will be taken care of by the service provider. Then at the service provider level, scheduling will also be taken care of. So how the resources are being provided. So for you as an end user, these resources will be infinite, but for the cloud service provider, according to them, there will be a certain limit on the resources. So they have to manage at their end how these resources are going to be provided. So that is taken care of by the scheduling algorithms. So there are different scheduling algorithms prevalent in cloud, like min-min, min-max, FCFS, and many others. So this all is taken care by the cloud service provider. And since in cloud the data is held at a third party location, so you're not aware where your data is. So this data is then prone to security breaches, security threats. So the security part is also taken care of by the service provider itself. So all these services, the administrator level services like pricing, SLAs, monitoring, scheduling, all these will be taken care of by the service provider, and security and how these data access is being done, this will also be taken care of by the service provider. Then the last level which we have is the data center level. At the data center level, what things are taken care of? Your computing resources, the storage resources, the network resourcing, all the kind of resources which are being used up, which are being demanded, which are being provisioned to the client, all these resources will be taken care of at the data center level. So the data center is a kind of heart and soul of the entire cloud infrastructure. So data center level is something you need to take care of. So this is the 3 schema architecture for cloud. So let's move further and see what are the different properties and characteristics of the term cloud. So a cloud should provide high scalability and elasticity. So what is elasticity? So when you have an elastic, what you can do is you can stretch it up, it will increase in size, and you can stretch it down, it will reduce in size. So this is how cloud computing will provide you with the resources. So if you need more resources, your resource usage will increase, you will be provisioned a lot of resources, and if you need less resources, these resource usage, these resource provisioning will go down. And this is something called as scalability also. Scalability, what does scalability mean? Your system is highly scalable. But what does that mean? It means that your system can support increased resource usage and it can support decreased resource usage as well. So if your system is highly scalable, so what it means is that your cloud computing service provider is able to provide you with these services depending upon your need on fly. So if you need more RAM, you'll be provisioned with more RAM. If you need less RAM, you'll be provisioned with less RAM. So this is a kind of elastic property of cloud computing. Then another property is high availability and reliability. So what does high availability and reliability means? Availability is that your computing resources should be available at all times and they should also be reliable. So what is happening now? You are being provided with the resources wherever you want. Whether you are in India, you are being provided with your resources, and even if you are in US, you can access these cloud resources. So this is the meaning of high availability and reliability. Then the next thing is that your cloud services should be highly manageable and they should provide these services in an interoperable manner. So what does manageability means? Manageability means that your services are manageable by the service providers. So if your resource usage is increasing, that is also manageable. If it is decreasing, that is also manageable. Then it should ensure high accessibility and portability. So what does portability means? Portability means that your system is highly portable. It can work across different platforms, whether you are working on an iOS, whether you are working on a Linux system, you are working on CentOS or Windows. Your system, your cloud services, they are portable. Then it should ensure that you achieve high performance and optimization. So high performance means that all these services which are being provided to you, they give you high throughput and the resources should be utilized in an optimal manner. So let's look at these properties in a bit more detail here. So what we can see here is the very first property is scalability and elasticity. So as we have just discussed, what does elasticity mean? That you can increase your resources, you can decrease your resource usage depending upon your requirement. So elasticity property, it supports scalability, and scalability means you can increase the usage and you can decrease the usage depending on your requirement. So how are these two properties met? One is it is met through dynamic provisioning and another one is through multi-tenant design. So what is dynamic provisioning is that you are being provided with the resources in a dynamic manner. So what does dynamic manner mean? So as and when you are using your resources, for example, if you're using say a Google platform for your resource usage, if you're using cloud Google platform and you are using say 1 GB of RAM and suddenly you need say 4 GB of RAMs. So what is happening here is you will be provisioned with these kind of resources dynamically. You're not aware that these your resource usage has increased. You'll be just provided with these resources in a dynamic manner, and this thing is termed as dynamic provisioning. We have different dynamic provisioning algorithms also, but that is beyond the scope of this lecture. Maybe in the upcoming series we'll discuss about dynamic provisioning. Then another property supporting scalability and elasticity is multi-tenant design. So you must have heard about the term tenant. What does a tenant mean? Tenant is someone who just lives in a place, and then that person pays rent, and depending upon their requirement, whether if it is a 1 BHK flat, they will pay for a 1 BHK flat, and if it is a 2 BHK flat, they will pay for a 2 BHK flat. So this is what a tenant is. But what we just said, we said about multi-tenant. So if like there are different students, so for example 5 students, if they're living in the same flat, so they are multiple tenants working in the same place. So what is happening is there are multiple tenants who are residing in the same area. So what they are going to do is they are going to share the rent, they are going to share the resources. So what are the resources in this case? The rooms which are being provided, these are a kind of resource. Then the electricity which is being provisioned, that is a resource. And water which is being used, that is also a kind of resource. So these multiple people, these multiple tenants, they are together using the same resource. So similarly in cloud computing, there are multiple people, multiple users who are going to use the same set of resources which are being provided by the cloud service provider. So henceforth, this is the property of multi-tenancy, which in turn supports scalability. So how do you think multi-tenancy is supporting scalability? So since there are resources for the cloud user, it is infinite, but for the service provider, it is finite. So if there are multiple tenants, multiple resources, these resources are being shared by multiple users. So this is the way in which the cloud service provider, it ensures that scalability and elasticity is taken care of. The next characteristics is high availability and reliability. So how high availability and reliability is ensured? High availability means that the resources are available at all the times. So how it is taken care of? It is taken care of by fault tolerance, system resilience, system security. So fault tolerance means it should be tolerant towards any kind of fault which is occurring, any kind of system resilience which is occurring, and of course any breaches to security. Everything is taken care of by the cloud itself. So this is a very important property of cloud computing. So these are the two properties, and of course we have other properties we'll be discussing in a while. Performance optimization, accessibility, portability, manageability, and interoperability. And of course, system resilience and system security will also be discussed in detail. And in this figure, you can see that we have written utility computing, and then we have written SOA plus SLA. So what does this signify here? It signifies that cloud, it comprises of these kind of resources like utility computing, software-oriented architecture, and service level agreement. Together, these things, they provision you with cloud. So these are the things, and these are the different properties of cloud computing. And apart from that, there is a property called performance optimization. So what does performance optimization means? It means that your whatever the performance is being provided to you at the service provider level, this performance is being done in an optimized manner. How there are different technologies which are involved, which we'll be discussing after a short break.
With this note, we would like to thank our expert, Dr. Kashish Shakil, for giving us this productive session on cloud computing. Friends, there is a lot more to discover, a lot more to learn. So you're requested to be with us as we are back after a short break. Thank you. Hello friends, welcome back to this session. Friends, as you know that today we are talking on cloud computing, and for the discussion on the topic we have with us in our studios Dr. Kashish Shakil. Dr. Kashish Shakil is Assistant Professor in Department of Computer Science and Engineering, Jamia Hamdard. So let's welcome our guest Dr. Kashish Shakil once again, and I would like her to explain us in detail the other aspects of cloud computing. Hello ma'am, welcome to the lecture.
Yeah, hello friends, welcome back. So before the break, we had discussed about scalability and elasticity and availability and reliability. And we had started off with performance optimization. So how the performance optimization is achieved by the service provider, it is achieved through parallel processing, through load balancing, and through job scheduling. So what parallel processing does is, it provides you with the resources, and it provides you with the resources in a parallel manner. Everything, all the computing is done parallelly, and then at the service provider level, the service provider, it does all the load balancing itself in a dynamic manner. So you don't have to take care of the load balancing aspect. That is taken care of by the service provider itself. At the service provider end, they have a lot of load balancing algorithms, which they are usually, the research is still in nascent stage in these kind of load balancing algorithms, so that you can get the maximum out of your cloud experience. And another aspect is job scheduling. Cloud computing service providers, they have different job scheduling algorithms through which these resources are being provided to you. And another property which is of cloud computing is accessibility and portability. So what accessibility does is that your computing resources are being provided in a uniform manner. There is a uniform access to these resources. So this access is independent of the geographical location. So if you are in US, you can access cloud resources. If you are, say, in Hawaii, you can access these cloud resources. So accessibility is taken care of by the cloud itself. Then another aspect of cloud computing is manageability and interoperability. So manageability is done through billing system. So different cloud providers, they have their own billing system. For example, Amazon EC2, it has its own billing system. Google Cloud System will be having its own billing system. So they have their different kind of billing systems Then they have to take care of the monitoring of the resources, so how the resources are being provided to the users, and if the resources are working fine or not. And on the basis of these monitoring also, they can develop their own scheduling algorithms. So if a user is using different resources, if a user is using more resources, these resources are being provided depending upon the kind of agreement they have signed, that is depending upon their SLAs, and if they're using less resources, and that is also being monitored, and that is also being taken care of by the service provider. Another aspect of manageability and interoperability is control automation. So you are not aware how these resources are being provisioned, you are not aware from where these resources are coming. Everything is done in an automated manner. You no longer have to go to some site, you don't have to go to any web portal, you don't have to go to any place to increase your resource usage, you don't have to sign up anywhere to decrease your resource usage. Everything is being taken care of in an automated manner. Nothing, you don't have to do anything manually. This is the beauty of cloud computing. Scalability and elasticity, what it ensures that to the end user, you as an end user, you are getting an illusion of unlimited resources. So for me as an end user, I don't have to worry about anything. I have an unlimited pool of resources which I can access. So what is scalability? Scalability is a desirable property of a system, a network, or a process which indicates its ability to either handle growing amounts of work in a graceful manner or to be readily enlarged, and of course to be diffused also. So it provides you with the ability to handle growing volume of resources as well as reducing resources. This is scalability. Then what is elasticity? Like we have discussed already, it is the ability to apply a quantifiable methodology that allows for the basis of an adaptive introspection in a real-time infrastructure. So if you are using a cloud infra, for example, say if you're using Amazon EC2 infrastructure, that is a kind of real-time infrastructure which you are using. So if on the fly you are increasing your resources, if on the fly you are decreasing your resources, everything is taken care of by this elasticity property of cloud computing. But what are the factors by which you can achieve these kind of properties? One is through dynamic provisioning, and second is through multi-tenant design. So what is dynamic provisioning? Dynamic provisioning is a simplified way to explain a complex networked server computing environment where server computing instances are provisioned or deployed for an administrative console or client application by the server administrator or a network administrator or any other enabled user. What is happening is you are being provisioned with these network of computing environment in a dynamic manner. So depending on your usage, you are being provided the resources, all the networked resources dynamically. So, but in case of traditional systems, there were two problems which occurred in dynamic provisioning. One was under usage and another one was overusage. So in case if it is underestimated utilization, what is happening is your system's capacity is more, but the demand is less. So what is happening here is there is a loss of revenue to both the cloud end users as well as the service provider. Because why it is a loss for the service provider? Because their resources are getting wasted, and not only their resources in terms of computing, there are other resources also involved at the back end, like electricity. Electricity is being wasted. And what else? How this electricity is being provided to you? How this electricity is generated. So there are the natural resources which are being provided, through which the electricity is being provided, that is also getting wasted. So there is a lot of wastage of resources. So this is a problem to both the service providers and of course to the users. How is it a problem to the users? Because for me as an end user, I don't feel that there is any problem. But the major problem with the end users is they might be capable of achieving more kind of resources. They might be capable of using more resources, but those resources somewhere down the line, they are not being provided to them in a dynamic manner, and these resources are getting wasted. Another, from this plot, we can see that how much amount of resources they are getting wasted. The capacity is much more and the demand is less. So these resources, they are getting wasted. So what can be a probable solution for these resources? How can we solve this wastage of resources? Maybe one of the answers can be we can provision them dynamically, but where does this dynamic provisioning of resources actually takes place? That is a question we need to think about. Then another is your capacity of your system is less, and what the demand is more. So in this case, what is happening is your demands are not getting met. You as an end user are at loss because your demand is not being met. And for me as a service provider, since I have to be in business, I'm earning a bad name because I'm not able to meet up to my SLA requirements. I'm not able to provide the users with the amount of resources that they actually want. So it is a drawback for me as an end user and for me as a service provider also. So in both the ways, it is a kind of drawback to us. So why do you think these kind of variations occur? There are different reasons for this fluctuating demand. There might be some kind of seasonal demand. So maybe during the day in some zones, the requirement for resources might be very high. So at this kind of time, the resource requirement might be at its peak, and the service provider, it might fail to provide you with these resources. Then there might be difference in the industry policies. So if I'm deploying a new business idea which requires a lot of resources, so at that point of time, me as a business user, me as a business client, I might be using a lot of resources, so I might be having a high demand at this point of time. And of course, at some point of time, many of you might think, okay, let's go and use these resources, let's go and play some game. At this point of time, maybe whole of India is engaged in doing some kind of activity which involves a lot of resources. So at this point of time also, your resource requirement will go up. And if me as a cloud service provider, if I'm not able to provide you with the resources, then what is the need of cloud computing? So the algorithms which are being developed for cloud, they should take care of this thing, that the gap between the amount which is demanded and the gap between the amount which is demanded and the resources which are being provisioned and which are being available, this gap should be reduced. So this thing should be taken care of by the service provider itself, and they should make sure that the cloud resources are being provisioned in a dynamic manner such that there is no over-provisioning, there is no under-provisioning, and similarly they should develop algorithms which should meet the demands of the users well. There should not be a gap between the resources which is available, the capacity of the cloud users, and the ones which are being provided. So another aspect is multi-tenancy. So we just saw what multi-tenancy is in literal terms. It can be, as we have just discussed, that it can be considered similar to a group of people renting out a flat. So in the same manner, what does multi-tenancy means? Multi-tenant refers to a principle in software architecture where a single instance of software runs on a server serving multiple client organizations. So what is happening as software in terms of multi-tenancy? There is only a single instance of a software which is available, and this single instance is serving multiple clients, multiple end users. So if, for example, me as a service provider, I have just one instance of say a software, say Java, which is available, and there are multiple people who are hitting on like, I want to use Java, I want to use Java. What is happening is the same server is providing Java to me as a client hitting from India, and the same server is providing the same resource, which is Java platform, to someone who is hitting on a demand from China or Japan or America. So there is a single software which is being used by multiple users, multiple clients across the world. So with a multi-tenant architecture, a software application is designed to virtually partition its data and configuration. Thus, each client organization works with a customized virtual application instance. So what is happening is cloud computing, it provides all these services through a technology called as virtualization. So what does virtualization does is it virtually partitions your data, it virtually provides you with different virtual instances of the same machine. So for example, if I have a RAM system with 16 GB of RAM, me as a service provider, I might just make different virtual machines on a single server, on a single machine, single physical machine. I am providing the users with different virtual machines. So on a single physical machine with 16 GB RAM, I might make, say, for example, 4 virtual machines, which can be providing to the needs of 4 different users. And these users, mind you, they might not be in the same geographical location, they might be in different geographical locations, because cloud computing is independent of the geographical locations of the users. Next property is availability and reliability. So what does that mean? Data is available every time and everywhere. So what do you think every time and everywhere means? So if I want to access my data from USA and it's 2 a.m. in India, I can access it. So this is data accessibility every time and everywhere. So I am not in India, I am in US. So I'm able to access my data at 2 a.m. from US. I'm able to access my data at 2 p.m. from India. So your data is highly available anytime, everywhere, every time. So let's look at the formal definition what availability is. The degree to which a system, a subsystem or equipment is in a specified operable and committable state at the start of a mission when the mission is called for at an unknown time. This means that the degree to which your system is available. So the time is not known, whether it is you want its availability at 2 a.m. or you want its availability at 2 p.m. So you are not aware of the time of the availability. It is at an unknown time. So your system should work towards achieving high availability at any point of time. So cloud system, it usually requires very high availability. For example, there is a system called 5 nines. 5 9 systems would statistically provide 99.9999% availability at all times, which is quite high. Then we had said availability and reliability, and we never talked about reliability. So what reliability is? Reliability is the ability of a system or a component to perform its required functions under stated conditions for a specified period of time. So whatever the condition is, your system must be reliable enough to handle it. So if the condition is like if there are 50 users, if this is the condition, your system should be robust enough, it should be reliable enough to handle this requirement. And if there are only 5 users, then also your system should be able to handle the requirements. But how do you achieve these properties? One is through fault tolerance, then through system resilience, and then is through adopting reliable security mechanisms. So what is fault tolerance? Fault tolerance is the property that enables a system to continue its operating properly in the event of failure of some of its components. So if there is a failure in, say, X part of a software, then also your software should be provisioned by the cloud service provider. And if it is a failure in, say, Y, X, both the components, then also your system should be able enough to provide you with the resources. So if it is operating, if its operating quality decreases at all, the decrease is proportional to the severity of the failure, as compared to a naively designed system in which even a small failure can cause a total breakdown. So if your system is not fault tolerant, why as a client I would go for a cloud model? I will rather sit at home and then develop a system of my own. I would rather buy a system of my own than going for some third-party cloud services. So fault tolerance is a property which needs to be maintained in cloud computing. So fault tolerance in turn has 4 basic characteristics. There is no single point of failure. There should be no single point of failure in cloud. Then fault detection and isolation to the failing components. Third is the fault containment to prevent propagation of the failure. And the last one is availability of reversion modes. So if it is a failure, how you will go back to the reverse, how will you go back to the reverse and go back to the point where failure occurred, and how this provider will ensure that everything works out smoothly. So fault tolerance is something which needs to be catered by the service providers themselves. Next is system security. So security is a very important aspect in terms of cloud, because in cloud, your data is not within your hand. It is, as we had discussed in the beginning, that in cloud, your data, your computing, nothing is in your hand. It's far away, similar to a cloud in literal terms. So if your data is far away, then this data might be prone to some kind of security breaches, because it's not at your location, it's at a third-party location. So how me as a client can trust a service provider who is a third party with my valuable data? So for that also, the service provider should ensure certain security mechanisms which needs to be taken care of, because without this, they'll just end up running out of the business. So some of the important security and privacy issues are, first one is data protection. To be considered protected, data from one customer must be properly segregated from that of another. So if there are 50 users who are using the computing platform, they are using the common cloud service provider, then their data should be segregated from that of the fellow users. So if I and one of my friends, we both are accessing the same cloud services, my friend should not be aware of what my data is. And of course, I should not be aware of what my friend's data is. So data segregation, data protection is very important in the cloud environment. Another important security aspect is identity management. So every enterprise will have its own identity management system to control access to information and computing resources. Identity management, what it takes care of is that only me, if I am a legitimate user, then only I should be allowed to access the cloud services. Not any other person should be allowed to access my cloud resources, and my data should not be available to anyone else. So identity management, identity crisis is something which is very important, a very prevalent and a very crucial security issue which needs to be taken care of. Then another issue is application security. cloud providers, they should ensure that the application available at a service provider via the cloud services are secure. So it is not like if I'm using, say, Amazon's cloud service and I end up infecting my own end device which I'm using. So what is the usage of that kind of cloud services? And of course, it will earn a bad name to the cloud service providers who are just nothing like someone who's promoting their own business. So why would I go for their business? Why would I support their applications? So you need to ensure as a service provider that all the applications which you are providing, they are secure enough. Then the next issue is privacy. The providers, they should ensure that all the critical data are masked and that only authorized users have access to data in its entirety. So privacy of data should be taken care of. So maybe this data can be saved in an encrypted form. So crypto algorithms are used for these purposes, crypto algorithms. Then there are other algorithms which are being used. Maybe some of the works, they use biometric applications also. They are using biometric signatures for such kind of things. I came across a work called as BAM Cloud for the same, in which they were using biometric applications to secure the data in cloud. So all these things, they should be taken care of, that there is no breach to the security and the privacy of the end users, so that the entire cloud ecosystem can work in an efficient manner. Then the next very important aspect of cloud computing is the payment mechanism. The payment mechanism in cloud is on the basis of pay per usage. So it is a very important term, synonymous with cloud computing, because you are going to pay only for the amount of resources you are using. So this is the central idea behind cloud computing, that you are going to only pay for what you are using. This is the entire thing which led to the evolution, to the revolution of cloud computing, that you are going to be provided with these services in a metered manner, in a pay per usage manner. So just keep on using the cloud resources and just keep paying. No need to buy any infrastructure, no need to install any infrastructure, nothing, just pay. So these are some of the properties of cloud computing which are very, very, very important. And for payment mechanism, there are different cloud service providers. They have their own payment mechanisms. So Amazon's EC2's payment mechanism is very different from that of Google. And of course, then you have other cloud providers also. So their payment mechanism is different. And there are certain payment mechanisms like that of Amazon EC2. They provide payment in an hourly manner. So if you're using a resource, say for 1 hour and 10 minutes, so you are going to pay for those 2 hours. You are not going to pay, say, for 1/10 of an hour. That is the payment mechanism of Amazon EC2. So everything in cloud is very important. So today we had looked upon what cloud computing is. So what do you think cloud computing is now? By the end of this lecture, you must be aware what cloud computing is, because it is the latest buzzword, a very in technology. So cloud computing, what cloud computing is, that you got aware of here. Then the different properties of cloud computing, like scalability, availability, reliability. So these are the things we covered up in today's lecture. In the upcoming lectures, we'll be seeing what are the different benefits from cloud computing, then what are the different cloud service deployment models, and what are the different soft service models for cloud computing. So I'm sure this lecture must have been very enjoyable and a learning experience to all the listeners. Thank you.
With this note, thank you, ma'am. Thank you so very much for giving us this productive session on cloud computing, where we tried to understand what cloud computing is, as well as we discussed on the properties of cloud computing. Dear friends, if you have any queries or if you have any feedback to be given to this particular lecture, then do write to us at info.cec@nic.in. The lecture is going to be uploaded on YouTube soon. So keep watching us and keep writing us. We would be meeting again soon. Till then, take care. Goodbye. Thank you, ma'am. Thank you once again.